we haven't talked about our friends from EEL Battery for a while, right? A few months, maybe 2 years ago, they sent over these batteries here. We've got a version 4 of their do-it-yourself kit and a version 5 of their do-it-yourself kit. But now, for quite some time, there is now a version 6 available. And they wanted to send me one to show you on the channel. I said, no, don't send any more boxes. I've got quite a few boxes already. Just send me the upgrade kits and I'll show you on the channel how it looks like. And this is exactly what they did. Look at this. This is how the version 6 of the do-it-yourself kit looks like now. So the box itself hasn't changed, right? It is just the front panel and how they have designed all the components. Of course, the older boxes still have a version 15 JK inverter BMS, but now the version 6 kit has a version 19 JK inverter BMS with a flat glass screen. Or alternatively, no screen at all. Is that the first and maybe only manufacturer of do-it-yourself kits which is offering them with screen and without screen? Because with the latest update for the version 19 JK inverter BMS, you can see all the battery data on one display. Yeah, so you need only one battery in your whole stack with a display, and it shows the information of all connected batteries and BMS in parallel. There's no need to have a display for each of your batteries anymore. Beautiful! They are pre-manufacturing now these boxes, similar to what Yixiang does, and it is all pre-configured now. So it's not coming in all bits and pieces and parts anymore. You get the whole front panel ready assembled. And look how compact this design is. Communication board BMS, a fuse and a circuit breaker all fits behind the front panel. If you are space constrained with all your batteries, consider the EEL do-it-yourself box here, because this is the one with the smallest footprint, yeah? Smallest dimensions of all these different batteries and do-it-yourself kits you can buy. These are the smallest. And because this is all pre-configured now, they have also torqued, marked and checked these connections. Marked. Ladies, all these marks, all the bolts, screws, everything is marked. And look at here, cable tie organizes the cables so they're not flapping around. Nice detail. The balance cables have these braided tape around it, so they are nicely organized together. Main, negative and positive are getting these rubber isolator caps. And look how good the design is with these flexible bus bars here. I really like it. How short they are. Here from the BMS to the breaker output to the main negative, very short. Here main positive coming from the battery, going into the fuse, and from there it goes to the terminal to the outside world. There's not much bus bar going on here, right? Yeah, and the display sits under the BMS there. Nice design. I really like they install the BMS here at the back side of the front panel and not at the compression plate, because sometimes when you tighten the compression plate, it starts bending a little bit and then puts pressure on the BMS. And we certainly don't want to put any force on the PCB of our safety device, right? Welcome back to the Off-Grid Garage, my friends. Welcome back to the show. And I'm not saying it is sunny hot today, because it is not. It is like 28 only, mostly cloudy, and we've got only 35 amps outside. So it's the ideal temperature to do some battery upgrade work. Okay, let's open the front panel here of this version 4. Yes, correct, this is version 4 with a breaker. Yeah, they stopped using these circuit breakers here because some customers complained they got too hot. Even I like this solution here with the lid, so the circuit breaker is actually a bit hidden. Let's take off the front panel and see what we actually have. Yeah, see, this is the inside from the version 4. There's only the display, the breaker and the communication board. And the BMS was still sitting against the compression plate here. They have now changed this whole design. And this is exactly the problem here. When this compression plate bends a little bit when you screw it in, yeah, it also bends the BMS and puts pressure on the PCB. Yeah, and that's how it looks like inside the box. We have seen this many times here, and nothing has changed to the version 6 of the do-it-yourself kit. I guess they only changed the compression plate slightly, took off these standoffs, and the BMS is now sitting on the back side of the front panel. Alright, let's have a look what's going on in version 5 of the do-it-yourself kit. I should put stickers on here so I know which version it is. Because who can keep up with that? Ah, yes, I remember now. Version 5 of that do-it-yourself box comes without a breaker, no breaker on the outside, and it has this A and L fuse here, which we still don't know if it has the rating and braking capacity and everything for a 48-volt battery. So complete system design change with the version 6 now. Alright, just remove the screws from the positive here. The negative still stays with the BMS, which is mounted in the battery. And I want to take off the front panel now and see if there's anything else we need to do. Yes, there's one more screw down here. Alright, and now we should be able to take this off. Ah, yes, I remember. This is the one with the heating pads. And we put this extra fuse inside here because none of the heating pad solutions out there have actually a fuse. They connect directly to the main positive of your battery without any fuse in between. And I'm not a fan of this at all. Not at all. Okay, let's take the display connector, power button, communication cables. And this frees up the front panel. This floppy disk cable is a total nightmare. Yeah, there you can see the heating pad connectors. And I've fused this one here with one of these glass fuses inside. 10 amps is fully sufficient, but it protects the circuit for the heating pads. Highly recommended to put this in. Yeah, and the negative is directly connected from the battery to the BMS. So and here you can see all three versions, yeah, version 4, 5 and 6. So first there was the breaker, then there was the fuse instead, and now we've got a fuse and a breaker. Look about this design change. Wow, it's quite a bit of evolution here, right? Yeah, and this was the fuse a bit in question, I would say. It says 250 amps here, but it neither says DC nor could I find any information. It's a SWI CANL fuse. And EEL gave me the information that this one is rated for, I think, 80 volt DC and 20 kiloamps of braking capacity. I couldn't confirm this information. I didn't find any information about this fuse here. There's this SWI fuse Bible out there. Yeah, it's a huge PDF document with all the SWI fuses out there. And this fuse was not in there. Neither is the new one in there, actually, which is a SWI fuse as well. We get to this in a moment. Yeah, but this was a bit of a complaint here back in the day when we reviewed this do-it-yourself kit. But now let's have a look at the version 6 of the do-it-yourself kit of the front panel. This has the same fuse as over there and the same breaker as over there. So we want to have a detailed look at both. Let me get the other camera here so we can read everything which is on this fuse. So this one here says protect fuse. Interruption current 100 kiloamps, AC/DC 600 volts, and it's a SWI fuse as well. It's an EV600 250 amps, obviously, and it also has a number there 16782, SCE logo and the word China. And this all sits on the SWI fuse holder as well. And this is the same fuse holder they have used before for the ANL fuse. If these numbers are true, this is actually a very decent and capable fuse for such a battery. And look at this small footprint here of this fuse. That is amazing. This is actually something which should be installed in every battery. The 250 amp rating here is fine because this fuse protects from a direct short. And with such a battery we have definitely more than 250 amps and it will trip very quickly. And with 100,000 amps of braking capacity, very, very good choice of a fuse, Mr. EEL. So, and here on the other side we have a very interesting choice of circuit breaker. This is an hydraulic mechanic circuit breaker apparently. And I've taken a photo of all the information on the sticker so we can better read them. So it says circuit breaker, then there's a number. At the top part there are some more numbers which don't mean anything to me. But then we've got a rated current of 200 amps, a maximum voltage of 80 volts, hertz, so the frequency is DC, so it's DC rated. The delay is D2, whatever that means. The trip current is 270 amps here. That is interesting. and the interruption current is 10,000 amps or 10 kiloamps, which is, by the way, 10 kiloamps is not enough for such a battery. Yeah, this is a 280 amp hour battery, and the internal resistance is so low there will be more than 10 kiloamps flowing, so this circuit breaker will not be able to interrupt the current. But we still have the fuse here with 100,000 amps of interruption current, and this is clearly capable of interrupting the current. So in case of a short, you may have an arc in here, but the fuse will definitely protect your whole circuit. So from this perspective, I think the choice is fine, because we have two levels of protection, a fuse and a breaker. Even though I must say the trip amps is 270 amps, yeah? So in theory, if the BMS doesn't trip at 200 amps the latest, you could end up with having 270 amps flowing through your battery, a faulty BMS potentially, and all these bus bars and connections, they need to withstand 270 amps at least. Are these bus bars rated for 270 amps? And here on the sticker you can also see that we have a load and line direction arrow. There's no further information in the technical documentation of this breaker if it is for bidirectional use. And this is exactly what we need for a battery, right? The document also doesn't explain what the hydraulic function of this breaker is. So at the moment it's just a word in the technical documentation. I'm not sure what it actually does and how it works. Okay, very nice from EEL Battery to send me the product data sheet for this circuit breaker as well. So the manufacturer is BSB. And it says here the B3 series product is a hydraulic electromagnetic circuit breaker which our company designed and developed by adapting international advanced technology. The circuit breaker consists of shell operating mechanism, contact arc extinguishing system, and hydraulic solenoid tripping device and other parts. Yeah, and apparently this circuit breaker is available from 1 amp all the way up to 300 amps, so that's quite a span. 1 amp circuit breaker, cool. All right, and down here, this in the red boxes, this is the 80 volt rated DC circuit breaker. We've got two of them in parallel, yeah? This is one unit. It is not like we have two separate circuit breakers in parallel. It is one unit, and it is also connected mechanically at the front. So if one side trips, it flips the other side as well. Current rating available for these two parallel sort of models are 101 to 250 amps. It says it here again, 10 kiloamps of interruption current. So here we've got more information. So it's a 2-pole, 200 amp, 80 volt DC rated, 2 poles, M6 studs, without barriers in between. It has no auxiliary switch, B series trip current. DC medium delay type is D2. What we have seen on the label means DC medium. And we also have some trip curves here. Very nice. Okay, so we have to look at DC medium delay. That's what we have. And this is the trip curve. Let me zoom in here a little bit so we can see something. All right, we've got the tripping time here on the y-axis in seconds and the rated current in percentage. So 100% means 200 amps. Yeah, at 200 amps, it says here around 8 seconds or so it will take until the breaker trips. And the sticker said something about 270 amps, which is then maybe like 150, what it says here on the screen, 150% or something. So, and then we will trip at around 2 seconds. Yeah, so that's actually not too bad. And of course, the higher the current is, the faster it will trip. The drawings, dimensions, yeah, and I think that's pretty much it. I'll link this document down below if you want to have a deep dive into this breaker and let us all know what you think about it and if this is actually cool to have such breaker. I know the Yixiyang version 1 do-it-yourself box, yeah, they had a similar breaker style as well, like the one in the EEL box. And this was actually one of my biggest complaints about this box, using such a breaker. And now EEL is using it again here, but in combination with a T-class fuse. So before we install this new front panel of the version 6 of the do-it-yourself kit to this older version 5, we need to take off this BMS, obviously. And we're also upgrading the box from a version 15 BMS to a version 19 BMS. Not that it is necessary, but it is just part of the upgrade. All right, we are taking off the negative as well. Take off the balance cables. Thankfully we can reuse them. We don't need this one either anymore. Alright, take off this wonderful bus bar. And this frees up the version 15 of the JK inverter BMS. The 200 amp version? Yes, it is. Oh, what's going on here? Heating cable. Alright, and now we should be able to just... this has a different connector for the heating port now. The version 19 has only a screw terminal and no actual plug anymore as the version 15 had. So we have to replace this cable with a normal cable and a 3mm ring lock. Let me see, we should be able to take this off quickly and easy. Yes. Okay, I quickly made one. This connects back to here. And the other side connects to the BMS directly. But before we do that, let's have a look what else we need to consider here. Oh, I hope this all fits. Okay, so these two are going on top, negative here, positive there, that's fine. We've got the positive for the BMS here. Got the balance cable connectors. That's pretty much it. Everything else is already done. There's no communication stuff, no display, nothing. Just these two balance cables, positive, and that's it. Wow. Okay, let me get this screw here under the bus bar for the heating pad. Not that I ever need a heating pad here, right? But I probably want to do some testing with it in the future. So it is actually good to have at least one battery here with a heating option. Okay, the bus bar is a bit in the way. All right, there's our heater negative. So positive coming from here, going into all these heating pads and then going into the BMS, and this connects it to the negative. Yeah, positive directly to the battery, negative through the BMS. Let's see if this fits in. Oh, my friends. Now we have problems. Down there. You may be able to see it, but the bolts coming out from the circuit breaker, they are so close to this metal, to the compression plate there. That is not funny anymore. No, they don't touch, but it is probably 1.5 millimeters maximum. Okay, they need to come off. I need to cut them off. What else might be in the way? Just checking on the two terminals down there. Connecting the bus bar, that's all good. There's heaps of space. Oh, I've forgotten one screw here. Oh yeah, doesn't matter. Balance cables have enough space. Here's enough space. Here's enough space around the fuse. This is all good. Yeah, this is the only concern I have. Let me know down in the comments if you have bought a version 6 of the do-it-yourself kit from EEL Battery. If you have seen this as well. Okay, let's take this off again here for a moment. Yeah, it is basically these two bolts. They are basically touching this support structure here. Almost, or a millimeter is almost touching. So if I cut them off and put an insulator in this area, we should be fine. So my friends, we have now cut down these bolts, and I've used some EVA tape with double-sided sticky tape and epoxy sheet, and we put a little bit of an insulation barrier here in this area as well. So, and now when we put the front panel back in, and let's do another trial first. See how this looks like. Yeah, down there you can see it. So if I push in the front panel now, yeah, we've got some space actually between the bolts and the isolator. And that is exactly as I wanted it. All right, problem solved. It's a do-it-yourself channel after all. All right, front panel the second. Got the heating cable connected. Heating cable is a bit of a nuisance. Oh. Yeah, that looks much better. And there's no, see it for yourself, there's no problem at the bottom of the circuit breaker. It's only at the top. But now that is solved, it's all good. So there it is a bit close to the standoff, so I'll probably take off this standoff. And let's have a look if there's any other, and the one at the bottom as well there in this area. All right, let's do this right now before we continue. So this one and this one needs to go, and hopefully they are just welded to the compression plate and come off easily. One. Number two. All right, all the other ones are not in the way. That's all good. Well, with the new version 6 box, you don't have these standoffs anymore on the compression plate, so this problem doesn't exist for you anymore. All right, front panel, the third and final. Oh, this heating cable. Oh, it is in, my friends, it is in. Okay, positive, 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 all goes to here, and the negative over here. Should we do the negative first? It doesn't really matter. Negative, tiny balance cable screw. All right, I think that's as good as it gets. Ah, here we go. Now. Yeah, you need to massage them in a bit. Yeah, perfect cover. Nice. Don't forget the rubber, right? Should I torque them? Yes. All right, and here comes the massage again. Get this over these. That may not work here in this case because there are too many cables connected. Probably have to make a little cut there. Over here. All right, that's probably as good as it gets. Okay, put these ones back in. All right, that's all done. That's the upgrade. Ah, almost. So this is beautiful. Okay, let's see if it works. It turns on, that's good. Oh, that's the old screen still. Shit. Okay, packs. Yeah, it has all these cell voltages here. Beautiful. Settings, we don't need. Alarm. There's nothing wrong with the installation itself. It is just the setup in the BMS through the app, which is missing. And that's why we have an alarm. So yeah, that is actually not too bad. I'm pretty happy with this version 6 of the do-it-yourself kit from EEL Battery now. So we've got the breaker here in the negative path and the fuse in the positive path. Ideally, the breaker should be in the positive path as well, because this is what we are turning off in case of a fault. But hey, 10,000 mechanical cycles it can do. I've done 11 now. It's good, they put also a QR code here on the outside of the battery box now. You can scan this one and download the app for the JK Inverter BMS. Very good detail. Quality control passed. Yeah, and the inside looks very, very clean. I really like it. This is the fuse connected to positive, and there's the main negative bus bar going to the BMS. Yeah, there is good 10, 11, 12 millimeters space in between, but potentially they can bend this bus bar a bit differently, so it stays a little bit further away from the fuse. I would like to see. Yeah, it is not too bad, but I think it can be optimized. And I know exactly why they went for this circuit breaker here, because of the space. Yeah, they have only limited space, and they can never fit one of these larger circuit breakers inside such a small box. There's just no space in here. That's why they went with these ones. I mean, considering we've got the fuse in there, I would use this one here more like a main switch to turn the circuit on and off. But be aware, the positive stays connected, it disconnects the negative only. While here with these ones, the breaker sits in the positive line. It would be actually really cool if EEL would sell these fuses here and the fuse holder separately, so people can buy them and upgrade all their batteries, because this is a fuse which I would like to have in each of these batteries here. That is a very compact and super safe protection for your battery. I will ask them and see if they can add this to their shop. Yeah, my friends, so far this video from today, upgrading this version 5 of the EEL Do-It-Yourself Kit to a version 6 of the EEL Do-It-Yourself Kit now. Well, we just replaced the front panel and the BMS basically, reconnected everything and it works. I've got not too much to complain about this battery. It's really good quality, the design is outstanding. They've got some minor adjustments to do, probably supply some insulation material there for the backside of the circuit breaker. So you just stick it on the compression plate and it gives you a layer of insulation then. I mean, if you want to really complain on a high level, yeah, they could supply some insulation material to insulate all these, maybe an acrylic insulation cover for the fuse, and here as well some insulation over this terminal, yeah, so it is not as open. Because this is the main positive of the battery, this is the main negative, and everything is exposed basically. But apart from that, the box now gets my full endorsement. Yeah, let me know in the comments down below, what do you think about the version 6 of the EEL do-it-yourself kit now with a T-class fuse, circuit breaker, version 19 BMS. Pretty good. As always, my friends, all the links about these products here you will find under the video, as well as to all my tools I'm using. Yeah, I'm still receiving quite a few emails where people ask, oh, where can I get this and this? It is all linked under each of the videos and on my website as well. Alright, my friends, thank you for your support. More videos are on the way. If you like this sort of content, give me a like, leave a nice comment under the video. If you are new here, subscribe. I want to see you back here. And until the next video, guys, when we probably get rid of these CATL cells. We've got an empty case there. So the EEL batteries go into the EEL case. How cute is that? Until then, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye.